Pluto is a remote and faint, more modest celestial body that was formerly a component of our local star system. Despite being recent and shocking, assertions made by well-known space scientists Michio Kaku and Neil deGrasse Tyson have returned Pluto to public attention. They suggested that this far-off object be on a probable collision trajectory with Neptune. They're not just speculating. They are advising that this small world may be heading in a risky direction, a path toward a catastrophic collision with Neptune. But how on earth could that happen? And what would the consequences be if such a massive event ever occurred? Are we witnessing some kind of bizarre cosmic figment? Or is there something far more real and far more terrifying? Pluto's orbit cuts alarmingly close to Neptune's. Neil deGrasse Tyson and Michio Kaku are sounding the alarm in the event that anything even remotely could be in for a bad outcome, a planetary mishap. Could Earth be in danger too? And more importantly, how is such a cosmic event even possible? Accompany us as we investigate the possible ramifications of a Pluto-Neptune impact. Pluto, a former planet that was reclassified as a dwarf planet, continues to be an intriguing topic in the expansive cosmos. As illustrated by current theories, from top-tier analysts, Pluto's trajectory is dangerously close to Neptune's. Space experts Neil deGrasse Tyson and Michio Kaku are both issuing warnings about a conceivable hazardous interaction between these two worlds, which may indicate a significant risk. Still, how feasible is such a scenario on Earth? Pluto's journey around the solar star is unique to all other celestial spheres in our planetary system. It takes an astonishing 248 Earth years to finish a complete loop. Since its identification, in 1930, it has yet to complete even one complete cycle. However, Pluto's curiosity does not end there. Its trajectory is defined by its exceptionally elongated path, deviating significantly from the mostly circular rotations of the principal planets. What intensifies Pluto's path's extraordinariness is its tilt, which is 17 from the solar plane. The route Pluto traces is significantly more irregular. This tilt is distinct from that of other planets, and its eccentricity adds layers of complexity to its orbital configuration. Arguably, one of the most intriguing features of Pluto's orbit is its overlap with Neptune's. For approximately 2 decades for each circuit, Pluto actually approaches the Sun closer than Neptune, contrary to what one might expect based on their conventional planetary placements. This brings up the standard question: why hasn't Pluto collided with Neptune? Explanation resides in the gravitational influences of surrounding planetary bodies. The investigation of Pluto's path began shortly following its revelation. Initially, astronomical researchers attempted to comprehend its distinct contrast to most other planets, whose loops are roughly aligned with the solar plane. Pluto's route stands out with its sharp angle and uneven layout. The enigma deepened, with the recognition that the orbit of Pluto indeed intersects Neptune's. Despite these irregularities, Pluto's path remains steady, standing as evidence of the subtleties of cosmic physics. The three-body dilemma in outer space entails figuring out how a trio of cosmic entities like Pluto, the Sun, and Neptune move and affect each other because of the gravitational pull they exert. It's akin to forecasting future alterations based on the initial positions and tugs of mutual gravitation. In Pluto's case, this issue demonstrates how Neptune's loop and the Sun's pull all operate in an interwoven way. The expressions asynchronous oscillation, VZK wobble, and orbital drift are essential to unraveling this puzzle, as noted by astrophysics specialists. What maintains the planetary bodies in their circular tracks is asynchronous oscillations. With regard to Neptune and Pluto, the fundamental meaning of this phrase is that when Pluto passes through Neptune's orbital path, it is located at a 90 angular distance away from Neptune. This angular separation is crucial in preventing conflicts between their paths. Orbital drift, by contrast, refers to the vertical motion of a body as it revolves. For Pluto, this indicates that when it gets closest to Neptune, or another giant world, it lies significantly above their orbital tracks, providing an added level of protection against potential crashes. An additional major component in this discussion is the VZK wobble. Three researchers, Zeldovich, Kolopov, and Kakuhu, analyzed the cosmic spatial dynamics of entities, described it. It involves how three astronomical masses like Pluto, Neptune, and the Sun exert pull on one another. Due to their widespread appeal, this influence determines how they move. In Pluto's instance, the VZK wobble provides insight into why its path to the Sun appears to be so erratic. Despite Pluto's movement seeming unstable, this wobble aids in keeping it flowing smoothly across vast durations. The VZK wobble reveals that, even though the cosmos may look chaotic and strange, principles and patterns still enforce some degree of order. These dynamics assist in sustaining Pluto's steady path, ensuring that it does not collide with Neptune or stray from its regular route. This interaction between the three bodies is crucial to grasping how space trajectories shift due to interacting forces. Analyzing it reveals more about Pluto, our planetary group, and even far-off galaxies and their stars' projections. In the late 1980s, demonstrations showed that even though Pluto's orbit is strengthened by stabilizing attributes, it remains erratic. Small initial deviations can result in dramatic divergences over centuries. Still, these orbital behaviors have been proven to astonishingly maintain equilibrium over comprehensive timelines. Assessing changes via later automated readings has helped us learn how the behemoth planets Neptune, Jupiter, and Saturn affect Pluto's revolution around the Sun. Neptune shares a distinct orbital correlation with Pluto, in which, for every 2 revolutions Pluto performs, Neptune completes 3. This synchronized relationship preserves Pluto's stability. However, Neptune doesn't act alone. Jupiter's immense gravity contributes heavily to keeping Pluto's track consistent. Saturn as well adds to this. Jupiter's colossal mass, as revealed by the mix of research, is powerful enough to secure Pluto's course for potentially an extremely long duration. Jupiter, Saturn, and Neptune are all working in harmony to guarantee that Pluto moves safely through space without running into these dangers. Baffling but crucial systems play a major contribution to the upkeep of cosmic order. Without such mechanics, our solar neighborhood would be significantly disrupted. Pluto and other objects from the turbulent realm could be thrown out or collide with others, completely setting off chain reactions with other astronomical objects. Particular concerns regarding Pluto and its interactions with Neptune in the future require an understanding of its motion. This provides a clearer picture of the vibrant and ever-shifting nature of the planet's cluster. Pluto's example illustrates how paths that appear to be unstable can lead to equilibrium through intricate gravitational and kinetic interactions. It also emphasizes the need for constant surveillance and scrutiny of such oddities to better comprehend where we fit in the universe. Delving deep into otherworldly realms frequently makes us confront the bizarre attributes of celestial bodies. Furthermore, Pluto's orbit is a perfect case of this irregularity. The theory of orbital disorder, which refers to the sensitive orbital dependence on initial data, can be clearly seen here. This suggests that Pluto's minimal changes in its speed or coordinates could greatly influence its far future path. Making use of computer-based forecasting has been very successful and beneficial for space. Scholars working to decode Pluto's behavior. These programs employ elaborate equations to simulate how Pluto and other bodies, like Neptune, interact gravitationally. By adjusting minor aspects within these forecasts, scientists can observe how even slight changes can result in completely different destinations. In the late 1980s, these surprisingly digital models revealed that, despite the fact that Pluto has stabilizing instruments like asynchronous oscillation and orbital drift, its journey continues to behave abnormally. If Pluto begins with just a tiny disparity in its location or speed, the position of the future may appear vastly new in just a few years. Yet, despite this randomness, Pluto's trajectory has endured across immense spans of time, spanning billions of years. That means Pluto's path has an underlying consistency, even though it may appear unruly at first glance. Predicting stellar orbits, particularly ones as inconsistent as Pluto's, remains a monumental task. At its heart, the unpredictability of these systems results in far future predictions riddled with unknowns. Although models built on math are outstanding for decoding and estimating the speed of the universe, they also emphasize our limitations. In these formulas, they heavily rely on the initial values, and even the tiniest error or modification can shift the result dramatically, making pinpoint precision a true challenge. Beyond the erratic tendencies of planetary pathways, Pluto highlights the constant evolution and flux of the solar system. Despite the fact that humans have discovered significant understanding of the stars, Pluto's oddities remind us how much still lies in the shadows. Deciphering how massive planets alter Pluto's movements gives us a broader understanding of the behavior of the solar system. It illustrates how each planet's location and presence can meaningfully influence the steadiness and direction of others in the structure. So why the sudden concern? Astronomers are suddenly speaking with anxiety about a possible collision between Pluto and Neptune. Even with all the cosmic laws acting to prevent it, Neil deGrasse Tyson, a well-known space scholar and a key promoter of cosmic knowledge, provides a unique perspective on the mysteries of our planet. Pluto's peculiar saga, as Tyson, recognized for his efforts in demoting Pluto to dwarf status, makes it easier to understand thoughts regarding the shifting tenets of orbital research and the general public's curiosity in the overlooked regions of the heavens. His stance on Pluto's label reflects the fact that we are constantly improving our knowledge of the solar neighborhood. He views the shift not as a slur, but as a critical point of clarification to our understanding of things that revolve around the outlook for our star. Tyson's orbit physics emphasizes continual education and adaptability. She interprets as complicated trajectories, like Pluto's, a symbol of how much more there is to uncover. The enigmatic nature of such inquiries keeps astronomy thrilling. However, while Tyson remains hopeful, his outlook on a potential Pluto-Neptune collision is far less cheerful. His apprehension about Pluto's destiny, once a full-fledged planet, is rooted in his recognition of the erratic behavior of these orbital dances. He acknowledges that Pluto has so far remained safe, but minor modifications accumulating over time might trigger catastrophic events on Pluto's path, particularly its overlapping zone with Neptune, which has an intricate spatial rhythm that may not always be in sync. In Tyson's perspective, even the slightest disruption in Pluto's path could result in huge consequences. If these imbalances grow over millennia, they could eventually result in chaos or even a crash of the planet. But such a development wouldn't happen in the near future. Instead, it would span unimaginable lengths of time, well beyond the reach of human civilization. Still, Tyson's hesitant tone calls for more vigilance and deepened investigation into Pluto's orbital pattern. Tyson isn't standing alone. Michio Kaku, a renowned theoretical physicist, also sees astronomical upheaval that might result from interactions between planets. Despite the fact that Kaku rivals Tyson's awe for the magnificence of the universe, he also recognizes the shaky balance of planetary orbits and the wild, unforeseen effects that may occur over time. Both Tyson and Kaku emphasize the significance of persistent space exploration into the planet-controlling invisible forces. Drift and our star-bound family's situation with Pluto. In the end, this illustrates how our knowledge of the universe is always changing. Each breakthrough leads to further intrigue. As space science progresses, the slim possibility of a Pluto-Neptune collision is a humbling reminder that outer space is packed with twists and turns, and even peaceful planetary paths can change drastically over time. These lessons from Pluto serve as a reminder to ponder the skies incessantly about the secrets that the stars still hold.